Hey everyone, and thanks so much for tuning into the deep dive.
Great to be here.
Today we're tackling, well, a really big one. The F-35 Joint Strike Fighter program. Now, I know what some of you might be thinking, isn't that just for military tech heads?
Yeah, it sounds that way on the surface.
But stick with us because honestly, this whole program, it has a surprisingly big impact on, well, pretty much every U.S. citizen.
That's absolutely right. I mean, when you're talking about a military program with a projected cost, what is it, trillions over its lifetime.
Trillions, yeah.
That's something we all should probably understand a bit better. So our mission today, really, is to unpack why the F-35 even exists, and maybe more importantly, why it should matter to you listening.
Exactly. And we've really gone through quite a bit of material for this. We looked at articles from AIA Aerospace Research Central, good old Wikipedia, of course.
Always a starting point.
A piece called Origin Story, How America Ended Up with the F-35 Joint Strike Fighter, and also a pretty detailed report from the Johns Hopkins University Applied Physics Laboratory.
Some solid sources there.
So let's dive in. Where did this whole idea even begin? What's the genesis?
Okay, so the F-35 program, it didn't just appear out of thin air. It basically grew out of merging two earlier projects back in the mid-90s.
Two projects.
Yeah, one was called the Common Affordable Lightweight Fighter, CALF for short.
CALF. Okay, sounds specific.
It was. That was a DARPA thing, actually. And it had two main goals. First, create a STOVL fighter for the Marines that's short takeoff and vertical landing.
Right, for operating off smaller ships and forward bases.
Precisely. And second, CALF was also looking for a modern replacement for the Air Force's F-16s, you know, the workhorse.
Gotcha. And the other project you mentioned?
That was JST, the Joint Advanced Strike Technology Program. This was a bigger Department of Defense level thing, kicked off around '93. Its main focus was broader developing tech for the next generation of strike aircraft to replace a whole bunch of older planes for both the U.S. and the U.K.
Like which ones?
Well, a big target was replacing the F-16, again, but also others. The DoD's bottom-up review back then actually recommended starting JAST while continuing the F-22 and the FA-18EF programs.
So it sounds like the core idea bubbling up was consolidation. Like, let's stop designing a million different planes.
Exactly that. The hope was, massive cost savings, development, production, keeping them flying. If you could create one basic design that worked for the Air Force, Marines, Navy, and our allies, that was the dream.
And there were allies involved right from the start.
Oh, yeah. The UK was a major partner, then Italy, Canada, Australia, the Netherlands, Denmark, Norway. Turkey was also in the mix initially.
Wow, quite the coalition. It really does sound like a massive undertaking from day one. And this led to a competition, right, to pick the actual believer.
It did. You had Boeing step up with their concept, the X-32, looked kind of different.
I remember seeing pictures, yeah.
And then Lockheed Martin had their design, the X-35. They went head-to-head.
And Lockheed won out.
Yep. In 2001, the decision came down. The X-35 was selected. And that concept demonstrator, that X-35, was then developed further into the F-35 Lightning TISA that we know or hear about today.
Okay, so that traces the lineage merging CAL and JAS, the big competition.
Yeah.
But let's pull back a bit. Why did the U.S. military feel it needed a joint strike fighter program in the first place? What was the big problem they were trying to solve?
The fundamental driver was just a lot of aging aircraft. Seriously, across the services, planes were getting old, nearing the end of their useful life, and needed replacing.
Like what specifically?
You had the Air Force's F-16s, obviously, but also their A-10 Warhogs. The Navy needed replacements for their older FA-18 Hornets, the A through D models, and also their EA-6B Prowlers for electronic warfare. And then the Marine Corps, they desperately needed something to replace their AV-8B Harriers, the jump jets. And that's just the U.S. side. The UK needed replacements for their Harriers, the GR7s and GR9s, and their Tornado GR4s, too.
So a whole fleet getting long in the tooth.
Exactly. Now imagine the sheer cost and the complexity of designing and building totally separate, unique replacements for every single one of those roles.
Yeah, that sounds prohibitively expensive.
Astronomical, probably. So the joint approach, the JSF idea, was really rooted in trying to manage those costs across the board.
It comes back to affordability then.
Absolutely. That was meant to be a guiding principle right from the start, not just making it cheaper to design, but also cheaper to build in large numbers and cheaper to operate and maintain over decades.
And part of that was trying to use the same parts across the different versions, right? Commonality.
That was the initial very ambitious goal, yeah. They were talking about, 80% parts commonality between the Air Force, Navy, and Marine versions.
80%, that sounds huge.
It was huge. And, well, it turned out to be much, much harder to achieve in practice than they first thought.
Oh, how so?
By around 2017, the actual commonality achieved was closer to maybe 20%.
20. Wow, that's a big miss from 80.
It is. And a large part of that, you have to assume, comes down to the very different things each service needed their version of the plane to do.
Right, they weren't just getting identical planes painted different colors.
Not at all. The Navy needed the F-35C, that's the carrier version. So it needed bigger wings for slower landing speeds on deck and much tougher, ruggedized landing gear to handle those controlled crashes onto the carrier.
Makes sense. Huge stresses involved there.
Totally. Then you have the Marines and their F-35B. They absolutely needed to keep that SIFO-VL capability, replacing the Harrier.
The jump jet ability.
Yeah, short takeoff and vertical landing. So they could operate from the smaller amphibious assault ships, not just the big carriers, and even from rough forward bases close to the fight.
And that required some pretty unique engineering, I remember reading.
Oh, definitely. The F-35B uses this really innovative shaft-driven lift fan system. Basically, the main engine powers a huge fan mounted vertically behind the cockpit to provide lift for hover and vertical landing. It was seen as potentially more efficient and less complex than having separate, dedicated lift engines like some older designs.
Okay, so Navy needed carrier toughness, Marines needed vertical lift. What about the Air Force, the F-35A?
The Air Force was looking for a workhorse, really, a multi-role fighter, the F-35A, to replace primarily their huge fleet of F-16s, but also step in for some of the A-10's ground attack roles. Their focus was on strike capability, but also having a stealthy platform that could work alongside their F-22 Raptors for air superiority and other missions.
So 3 very distinct sets of requirements driving divergence from that common core.
Pretty much, yeah. Which helps explain why that 80% commonality target was so hard to hit.
Okay, so we understand the origins, the initial goals, the different versions. Let's pivot now, really focus on why this matters to, the average person listening. Why should someone who isn't tracking defense budgets care about the F-35?
Right, and that's maybe the most important question here. Fundamentally, the F-35 program is about national security. It's about ensuring the U.S. maintains its technological edge in air combat.
Keeping the country safe, basically.
At its core, yes. In a world where potential adversaries are constantly developing their own advanced capabilities, the F-35 is designed to be a tool to deter conflict, protect U.S. interests, and give our forces a decisive advantage if deterrence fails.
So maintaining that military edge is crucial.
It's seen as vital, and the original idea behind making it a joint program was that this was supposed to be a more cost-effective way to achieve that necessary modernization compared to, say, the Air Force, Navy, and Marines, each developing their own completely separate stealth fighters.
Even though the commonality wasn't as high as hoped?
Even with the lower commonality. The argument is that using a common baseline design, common manufacturing processes, common logistics, and training elements, it still offers significant potential savings over 3 or more completely independent programs to replace all those older jets we mentioned.
Okay, so there's a national security argument and a potential cost efficiency argument, even if debated. What about the international partners? How does that connect to the average American?
That's another key piece. Having allies like the UK, Australia, Italy, Norway, and others flying the same aircraft isn't just about them helping to share the massive development costs, although that's part of it.
Right, spreading the dough.
But it also significantly improves interoperability. It means we can train together, operate together, share logistics more easily. It strengthens those alliances, and stronger alliances generally contribute to greater global security and stability, which is ultimately good for the U.S.
Okay, that makes sense. Shared platforms, stronger teamwork. But we have to talk about the cost. You mentioned trillions over the lifetime.
Yeah, the numbers are staggering. The projections vary, but often hover around the $2 trillion mark for the total program cost over its entire lifespan, including development, purchase, operations, sustainment, everything.
$2 trillion.
It's an almost incomprehensible amount of money, and that is a huge reason why every U.S. citizen should care. That's taxpayer money.
Right.
Understanding why that money is being spent, how those decisions get made in Washington, what the long-term financial commitments are, that's just part of being an informed citizen, holding government accountable.
Absolutely. And beyond the cost, are there technological aspects that matter beyond the purely military sphere?
Well, yes, potentially. The F-35 is packed with cutting-edge technology. You've got highly integrated digital systems, sophisticated stealth coatings and shaping.
The stuff that makes it hard to see on radar.
Exactly. And then there's the sensor fusion. The plane gathers vast amounts of data from its own sensors and from other sources, fuses it together, and presents the pilot with this incredibly detailed picture of the battlefield.
Like augmented reality for pilots.
Kind of, yeah. Now, these technologies are developed for military needs, obviously. But often, advancements made for defense programs in material science, in computing, in data processing can eventually trickle down and find applications in the civilian world. It can spur innovation.
So maybe spin-offs down the road that benefit everyone.
It's certainly a possibility. That's often part of the justification for these big R&D investments. But look, we need a balanced perspective here. The F-35 program hasn't exactly been smooth sailing.
Right. We've definitely heard about the issues, cost overruns, delays.
Absolutely. The program has a well-documented history of costing significantly more than originally projected and taking longer to develop and field. There have also been ongoing debates and concerns raised about its performance in certain combat scenarios, its reliability, its maintenance costs, even safety questions at various points.
And I remember reading about cyber espionage concerns, too. Like other countries trying to steal the plans.
Yes, there have been allegations and reports over the years about attempts particularly linked to China to conduct espionage targeting the F-35 project.
Why is that relevant to the average citizen?
Because if an adversary gets their hands on the secrets behind the F-35's advanced technology, its stealth, its sensors, its systems, it erodes the very technological advantage the plane is supposed to provide. That could put our pilots at greater risk and undermine the massive investment made. It speaks to the critical importance of cybersecurity and protecting national secrets.
So the security aspect cuts both ways, needing the tech but also needing to protect it.
Precisely. And just to put a finer point on the cost again, back in 2012, the projected average annual cost of the program was already around $12.5 billion a year. That kind of sustained financial commitment really underscores why understanding this program matters.
Okay, so it's complex, huge potential, huge costs, significant challenges. Let's talk a bit about how a program this massive was actually managed. We know CALF and JAST merged, but how did the DoD structure the development?
They set up the Joint Strike Fighter Program Office. This became the central hub within the Department of Defense for managing the development of these next-gen strike aircraft.
So one office overseeing everything.
Essentially, yes. And a key focus right from the start was this idea of joint acquisition, getting the Air Force, Navy, Marines all working together under one umbrella. Another big emphasis was on transitioning advanced technologies out of the labs and into an actual buildable, affordable aircraft. Affordability was stressed, remember?
Right, cost is a key factor. Was there a specific process they followed?
They talked about using a strategy to task to technology approach, which sounds kind of jargony.
A little bit, yeah.
But the basic idea was to involve the actual users, the pilots, the maintainers, right from the beginning, alongside the engineers and developers. Define the mission needs first.
Yeah.
The strategy and tasks. Then figure out what technologies you need to achieve those missions effectively.
Instead of just building cool tech and then figuring out what to do with it.
Hopefully, yeah. They used a lot of tools to try and define those future needs accurately. Lots of computer modeling, simulations, detailed analyses, trade studies comparing different options.
Trying to predict the future of warfare, in a way.
Exactly. They even ran extensive war games.
War games. Like computer simulations of conflicts.
Pretty much. High-tech, incredibly complex simulations to assess how future strike forces might perform, what kind of abilities would be most important, and where potential weaknesses might lie. It helps shape the requirements for the aircraft.
Interesting. And you mentioned cost being key.
Yeah, another concept they really pushed in the JSF program was cost as an independent variable. Meaning, instead of designing the plane and then seeing how much it costs, they tried to set cost targets as a primary constraint right from the outset. Design decisions, technology choices, they were supposed to be made with that cost target firmly in mind.
Trying to bake in fiscal discipline from the start.
That was the goal, anyway. They also funded specific efforts to mature key technologies before locking them into the final design, hoping to reduce risk. Things like the JSF Integrated Subsystems Technology Demonstration, or JIST, and the Advanced Lightweight Aircraft Fuselage Structure Program, ALAFS. These were about proving out tech for things like advanced structures or integrated systems to lower weight and cost.
So lots of background work before bending metal on the actual prototypes.
A huge amount. They even developed something called a virtual strike warfare environment, or VSWE, basically a massive simulation space to test concepts and analyze performance digitally.
Fascinating. And all this background work, the requirements, the simulations, it eventually led to that competition and the selection of Lockheed's X-35. What was special about the X-35 demonstrator?
The X-35 was the proof of concept. It was the plane that convinced the DoD that Lockheed Martin could meet the requirements. Crucially, they built and flew 3 distinct versions to demonstrate they could handle the different service needs.
The 3 variants we talked about earlier.
Exactly. They had an X-35A for conventional takeoff and landing, CTOL, like the Air Force needed. They built the X-35B with that shaft-driven lift fan for the Marines' STOVL requirement. And they had the X-35C with the bigger wings and stronger gear for Navy carrier ops, CV.
So they actually built and flew demonstrators for all 3 modes. That's impressive.
It was a major part of winning the competition, showing they could make all 3 work from a common baseline. And that X-35B lift fan system really was seen as a major innovation for STOVL flight.
That seems like a key piece of tech. Now, were those X-35 prototypes basically what we see today as the F-35, or were there big changes?
There were definitely changes, refinements made as it moved from a demonstrator to a full production combat aircraft. For instance, the nose section of the F-35 is a bit longer than the X-35's was to make room for all the mission electronics. The horizontal tail surfaces were moved further back for better balance and control. The engine air intakes were redesigned. The main fuselage got sort of fuller to accommodate the internal weapons bays needed for stealth. Small changes, maybe, but significant ones to make it a truly operational fighter.
So a clear evolution from X-plane demonstrator to frontline fighter. Okay, let's try and pull this all together then. Thinking about our listener again, what are the absolute core takeaways? Why should the F-35 program matter to the average U.S. citizen?
I think it boils down to a few really critical points. First, national security. Like it or not, the F-35 is set to be a central pillar of American air power for decades. Its success or failure directly impacts U.S. defense capabilities.
Okay, number 1, security.
Second, fiscal responsibility. We're talking trillions of dollars. Every taxpayer has a stake in understanding how that money is spent, whether the program delivers value, and how it's managed.
Number 2, the money. Makes sense.
Third, technological advancement. This program pushes the boundaries in aerospace, computing, materials. Understanding it gives you a window into cutting-edge innovation, some of which might eventually impact civilian life.
Number 3, technology.
And fourth, international alliances. The F-35 is a massive collaborative effort. It affects and reflects our relationships with key allies around the globe, which is crucial for global stability.
Security, money, technology, alliances. Got it. So it's really woven into the fabric of national policy in a lot of ways.
Absolutely. It's so much more than just, a cool-looking jet. Understanding the story behind it, the goals, the challenges, the costs, the capabilities, gives you real insight into how incredibly complex national defense strategy is shaped and carried out. The tough choices involved.
That definitely gives us all a lot to chew on. So maybe a final thought for everyone listening as you process all this. Given that we clearly need advanced military tools to stay secure, but these tools come with such, astronomical price tags. How do we strike the right balance? How can we as citizens stay informed enough to contribute to a meaningful discussion about ensuring both our security and responsible use of our national treasure?
That's the multi-trillion-dollar question, isn't it?
It really is. Something to keep thinking about.
Indeed.
Well, thank you so much for joining us on this deep dive today. We really hope this was informative.
Hope so too.
We definitely encourage you to check out the sources we mentioned if you want to dig even deeper into this complex and, frankly, fascinating topic. Thanks for listening.